Everybody, my name is Paul Dietrich, and today we're actually going to start a three-part series on how to solve systems of equations by three methods. So the first one is going to be elimination, my personal favorite. The next one will be solving a system by graphing, and then solving a system by substitution. So if we actually look at the paper, one of the first things we actually have to talk about is what is a system, right? So if you actually look at the paper, the example that we have two equations, so it's kind of like something that we're already familiar with. We kind of already know how to solve just a regular linear equation, but we're used to one major difference. If you look at the example, we have x and y. We have two variables that we're trying to now solve for. And as such, we actually have two equations. So what does this kind of even mean? Like, why the two variables? Why the two equations? A very, very short way to describe what we're trying to do when we're solving a system is basically kind of just like a linear equation where there's one variable. What we're trying to do in that one variable equation is we're trying to figure out what the value of that one variable is. Whether it's -2 or it's a decimal or, whatever, we're trying to find the value of that variable. And the value of that variable makes that equation true. What I mean by that is, let's say we had, for example, 4x equals 8. Well, then we would know that x has to equal 2, because 2 times 4 equals 8, and 8 equals 8. It's a true statement, right? So what we're trying to find in a system, and a system is just, it's two or more equations that we're trying to solve for. What we're actually trying to find is we need to find not only x, but we need to find the y. Those two values. We need to figure out what those two values are that not only make this equation true, but also make this second equation true as well. So just for example, let's say that x was 2 and y was -5. And we had this side of the equation equaling the other side. Well, x also has to equal 2, and x also has to equal -5 for the second equation as well. So it's a little bit more difficult. It's much, much more difficult to try and guess and check that way than it would be, for example, a linear equation. So let's get started. We're actually going to start by what's on the paper here, solving systems by elimination. Again, elimination is my favorite, so let's do this. Looking at the problem, what we have is, and this is why it's called elimination, is what we want to do. It's a strategy. We want to eliminate a variable, and it doesn't matter if it's x or it's y. We want to get rid of one of them right off the bat, because then it makes instead of solving two variables, we're only solving one, and that's a lot more simple. So if you can actually see here, here's a -4x and here's a +4x. I can actually add those, and these guys will cancel out, right? So that's actually the strategy we're going to use. We're going to, using elimination, we want to actually start adding these two equations by column. So what we're going to do is, let me draw not that color, let's do purple. Just a line, right? And we are actually going to just start to add these by column. So what I mean by that is we're literally going to take this first equation, this column, and we're going to add it to this equation in the same column. So I'm literally going to, so many colors, add them together. All right, here we go. So first things first, if you notice, -4x plus 4x, what happens here? Those guys cancel out. There's nothing here. So there's nothing. That's 0x. So literally I can just put, I just cancel out. It's gone. Okay, but here's the next part. -2, or this -2, plus a +8. Well, that's going to be +6y equals, think about this, you have a -12 plus a -24. Well, in this case, we have a -36. And check it out. Now we just have literally it's a one-step linear equation. all we got to do, we got to get y by itself. I'm going to divide both sides by 6. The reason why I'm dividing is because the 6 and the y are being multiplied to each other. So the inverse of that would be kind of like you say the opposite of multiplying, it's dividing, right? And so 6 is canceled. So all I'm left with is a y on this side equals negative 36 divided by positive 6. So remember we have, well, 36 divided by 6, we know that's a 6, and a negative divided by a positive, that's a positive, right? Oops. Everybody makes mistakes. A negative divided by a positive is a negative. It happens to all of us. Mistakes are okay. I'm going to box this in here. Okay, so what we just did is that we found that y equals negative 6. This is good because we've already found one variable. Now all we have to do is plug in our negative 6 into one of the original equations to find out what x is. So let's just say I'm just going to plug it into that second equation, right? So what I'm going to do is this. I'm going to, what's the best way to show this? I'm going to do a little, I'm not sure. Okay, I'm going to do this. I'm going to point which equation I'm going to put it into, and then I'll start up here. So here's that second equation. It's 4x plus 8y equals a negative 24. Okay, now here's the cool part, right? This part maybe might have seemed a little bit longer, but this part is much, much shorter. So what I'm going to do is I'm just going to rewrite my equation, 4x plus 8. Now all I'm going to do is instead of saying 8 times y, I know what y is. Y is negative 6. So all I have to do is replace this y with a negative 6. Because that's what y is. Equals negative 24. Okay, so I got 4x. And then 8 times negative 6, that's a negative 48. So minus 48 there equals 24. Okay. Now we're in that. We still, with this whole thing, we just have one equation, so this is good. I need to get x by itself. I have to get rid of this negative 48. I'm going to add 48 to both sides. I talk so fast. I had so much coffee today. That's how fast my mind is going right now. Okay, add 48 to both sides. The reason why we did that, those 48s are gone. So the only thing left on this side is 4x equals, I got my minus sign there, 24. Negative 24 plus a positive 48, that's a positive 24. Divide both sides by 4. 4's cancel. All I'm left with is x equals 6. Alright, so I just found two variables for both equations. Now here's the thing, I have to check to see if it's right. Okay, I don't want to just find the two answers and kind of assume that I'm correct. What you want to do is just double check, always double check, right? The way you double check is you actually just plug these two answers in to any of the two, and actually you can plug them into both of them. You'll know that you get it right if for both equations one side equals the other, right? So let me do a very squiggly box and we will check our answers. Okay, so let's look at that first equation, right? So here's that first equation. Right. So negative 4. Now, instead of saying negative 4x, we know what x is. It's 6, right? So I'm going to take this, put a 6 in, minus 2. Now, instead of saying minus 2y, I know what y is. It's a negative 6. So I'm going to replace this with a negative 6 equals negative 12. Okay, here we go. So negative 4 times 6, that's a negative 24. Negative 2 times a negative 6, that's a positive 12. This all equals negative 12. And if you look, negative 24 plus 12, that's negative 12. Look at that. Negative 12 equals negative 12. Boom. That means these two answers were correct for that equation. Okay, we got one last check. Ooh, I'm running out of paper. Like, we can do this. We can fit it in here. All right, last equation. Here we go. Line it up. All right, here we go. We have 4. Now, instead of saying 4 times x, we know what x is. It's 6. Plug that in. Plus 8 times, instead of saying 8 times y, and well, y is it's negative 6, equals a negative 24. All right, so here we go. Here's our check. 4 times 6, that's 24. 8 times negative 6, that's a negative 48, equals negative 24. And check this out. 24 minus 48, that's a negative 24, equals a negative 24. We just did it. We just found 2 answers. We found the 2 values for 2 variables for 2 equations in, like, I don't know how long this video was. It's definitely less than like 6 minutes, I'm pretty sure. But awesome job, guys. Stay tuned for the second video where we start to solve a system of equations by graphing. We'll catch you later. Out.